Hello wonderful person, this is Anton, and in this video we're going to be discussing one of the biggest mysteries from the James Webb Space Telescope once again. The mystery coming from the oldest and the darkest parts of the universe that even after years of research are still not completely explained. And that's because in these regions, instead of just finding a few faint galaxies and a bunch of baby stars, researchers discovered hundreds of strange, tiny glowing objects that nobody has ever seen before until these discoveries by the James Webb. And as you might know already, these have now been officially named Little Red Dots, or LRDs. Objects that seem to appear a few 100 million years following the Big Bang, but seem to completely disappear within about 1 billion years afterwards. And this by itself is very surprising because originally, researchers expected to find assembling galaxies and essentially a bunch of diffuse objects growing and developing in size, forming modern galaxies. And well, instead, they found a bunch of objects that are doing something they shouldn't be doing at all. Essentially, they're incredibly compact, very small in size, and seem to shine with the power of billions of suns. And while for the past 2 years, a lot of these objects have triggered a massive amount of different studies and a wave of scientific papers trying to explain what's going on here and how this is possible. Mostly because this challenges our basic understanding of how the universe should work. And while we've actually discussed these objects not so long ago, and you can learn about some of these recent discoveries in previous videos in the description, but it just so happens that it didn't take long for new studies to come out and for new discoveries to be made, because this is basically one of the biggest mysteries in astronomy. And once again, these studies suggest that these dots might not be what we first thought and might represent somewhat strange objects. And so I guess the question is, are these actually based on supermassive black holes producing these powerful emissions? Or could these be exotic, unusual stars that we've just never seen before? And well, I guess let's find out based on these recent studies you can find in the description. So we have a study by John Chisholm and the team you see right here, a much more recent study by Pierluigi Rinaldi, who actually has a very exciting proposition, and another one by Colin Burke that makes another unusual discovery that nobody ever noticed. But I guess very briefly, let's discuss their initial discovery and why they're so mysterious. And everything actually started in late 2022, early 2023. Here, when the first JWST surveys came out, astronomers like Ivo Labe noticed that some of these sources seem to be uncomfortably massive, at least compared to what we expect to exist in this extremely early universe. But at the same time, they seemed to resemble tiny dots because they were actually very small, under 1000 light years across, or at least 100 times smaller than the Milky Way galaxy, with one of the defining features of these objects being their somewhat V-shaped spectrum. Or basically, if you look at the light emitted from them, they seem to contain a lot of ultraviolet light and a lot of red light, but basically nothing in between, which formed a V-shape. And this V-break usually happens at very specific wavelengths, very close to what's referred to as the Balmer break. And while at first scientists actually thought that these might be just these huge evolved galaxies that somehow managed to exist very early. Except that there was a bit of a problem. If these were physical galaxies, their masses would be unphysically large, basically implying that they somehow converted all of the galactic gas into physical stars inside a very small volume of space, or basically implying some kind of 100% star conversion efficiency that we've just never seen anywhere. And so that explanation suddenly did not make sense, which forced astronomers to start to look for other sources of this power. For example, maybe these were active galactic nuclei or these ridiculously massive, powerful black holes. And what we're seeing are the glowing regions around supermassive black holes, which are producing all of this light. But the problem here is that normally these black holes also are supposed to produce a lot of X-rays, and none have been seen here. Although, as we've discussed in one of the previous videos, there are some little red dots that seem to produce them, but most don't. And so if these are black holes buried inside dense cocoon of gas, and especially active black holes producing a lot of emissions, they should be blasting so many X-rays that all of this should be visible from everywhere. But all of the recent data from NASA's Chandra X-ray Observatory confirm that there's almost nothing coming out. The majority of these objects are X-ray weak, or are basically 10 to 100 times fainter than a typical normal black hole of the same size and the same mass. But at the same time, there is actually something else that was detected here that makes scientists believe that something massive is indeed in the center. And that's because when scientists look at the cocoon of gas around these objects, they also detect something referred to as the broad emission line, specifically a line referred to as H-alpha. And here the line is broad simply because whatever is producing these wavelengths is actually moving at very fast velocity around something. And so we're basically seeing a lot of blue shift and red shift as if something was spinning around the center very, very fast. And this swirling motion in thousands of kilometers per second implies that there is something very, very massive inside. And well, right now, technically, only a black hole should be able to produce this, which led some scientists to propose this explanation. Maybe this is just a very strange black hole star. Or basically the black hole is still there, but there's this very thick gas cocoon that seems to block most of the emissions, and a lot of gas around this object then starts to glow, resembling a kind of a star-like object. In other words, so far there have been a lot of different intriguing and exotic propositions, but none of these explanations so far seem to touch on everything we observe. Which brings us to this fascinating recent proposition led by astronomers like John Grissom at UT Austin. What if these are not black holes, but instead globular clusters in formation? In other words, the other mysterious astronomical objects whose origin is actually not particularly understood. And in this model, the V-shape comes from different things working together. The blue part of the light comes from thousands of young normal stars that have just started forming inside this cluster and are basically very similar to your typical Wolf-Rayet star we see in the Milky Way. But what about the red part? Well, that could be coming from something else. Maybe a single supermassive star, also referred to as SMS, that could be a kind of a theoretical monster star, with a mass of tens or even hundreds of thousands of solar masses that some scientists have used to explain the existence of supermassive black holes so early on. In other words, this could be an extremely massive central object that's not really a black hole star, but is just your typical star, created by a sudden collapse of dust in a single point. And naturally, because of their mass, these stars would not live very long, maybe even under 1 million years, but would resemble these very massive, very large red stars, with a temperature that's even cooler than the sun, essentially mimicking a red light we see in a little red dot. And though this once again might sound like a somewhat far-fetched explanation, here, theoretically, this could solve certain mysteries in the Milky Way. And specifically here, the old globular clusters we have in the Milky Way do have a strange chemical fingerprint, such as high amounts of elements like nitrogen and aluminium, that we know usually only forms in extremely hot massive stars and not stars we see in these clusters today. In other words, it implies that many globular clusters in the Milky Way galaxy most likely contained a lot of these very ancient hot stars. But naturally they all went supernova and potentially produced a bunch of stellar remnants such as neutron stars and black holes. And since we've actually detected neutron stars inside globular clusters, there's maybe some evidence for that as well. And so if little red dots are indeed these globular clusters forming around monster stars, then we're finally seeing the parents of the star cluster for the first time. But naturally, there are still some unanswered questions from this explanation as well. For example, what exactly happened to that supermassive star at the end? Now, in this framework, the explanation suggests some kind of a heavy mass ejection and collapse, or basically there would be a lot of stellar wind that throws off a lot of elements from inside the cluster, with the object then collapsing into some kind of a black hole, or potentially explodes completely in the parent stability supernova. But the problem is that no such black hole so far has been identified in any of these globular clusters. And so until we actually find something like this in a cluster, this is obviously going to remain a hypothesis. Nevertheless, this hypothesis is still pretty solid. For example, it does explain the overall number of the clusters, because the number of little red dots discovered so far seems to align with the number of globular clusters in the local space density. At the same time, the redshifts where we see these little red dots corresponds to the overall age of an average globular cluster right here in the Milky Way. And at the same time, if we compare their luminosity to the total mass, or basically compare their total brightness to how much stuff is inside of them, it surprisingly seems to match the observed mass distribution for local globular clusters once again. And so there are definitely quite a few unusual similarities. But naturally still just a hypothesis for now, with additional clues coming from this study and another strange object now nicknamed saguaro. And while at first glance this doesn't look like a little red dot, because you can actually see a beautiful spiral galaxy around it. But here researchers performed a really intriguing experiment. They basically artificially moved the entire object much farther away in order to see what it might look like from a distance, or basically how this galaxy would look like from the edge of the universe. And because of surface brightness dimming, a phenomenon where light from the extended object gets spread out and becomes invisible to our sensors, surprisingly these spiral arms completely disappeared. And what was left behind was basically a bright red compact core. And that is actually a really surprising discovery because it implies that these dots we're seeing might be centers of much larger galaxies that are simply way too far and too faint to physically observe. And to test if this applies to many other little red dots, here the team compared images from 99 photometrically selected little red dots with the images revealing very faint, diffuse extended emissions surrounding the compact cores, basically confirming the presence of a host galaxy that might be undetectable in individual single-object images. But by stacking across different redshifts and by processing these images slightly differently, it might become possible to see the galactic shape, which technically makes this particular discovery the most exciting so far. Because assuming this is correct, it would actually present us with a slightly different mystery that's then even more difficult to explain. The mystery being, okay, so why are we seeing so many bizarre, massive, fully developed galaxies so early on? And though this would obviously resolve one mystery, basically these are not exotic objects and are just ordinary early galaxies, and we're essentially just seeing dots because this is a type of an observational bias, it still doesn't make life for astronomers much easier, because it would solve one mystery but present us with a new issue. But in the end, so far all of these are still propositions and not conclusive evidence, because for all we know, maybe little red dots could also be just different objects, or this could be a mixed population of things that do not have a single explanation. And so maybe some of them could be based on black holes, some of them could be globular clusters growing and developing, and basically involve these monstrous star-like objects, and some of them could be distant developing galaxies. Whatever this is though, the implication for astronomy in the next few years is going to be huge. Because if all of these explanations make sense, it means that black holes existed much earlier and managed to grow really fast. It also means that globular clusters began as these very exotic, very strange, extreme stellar objects. And it also means that galaxies formed very early and developed super early too, with this whole thing now becoming its own field. It essentially went from, hey look, this little red dot looks kinda cool and interesting, but what is this anyway? To now becoming a fundamental quest in astronomy to understand the origins of many different objects and helping us understand that all of this is just the tip of the iceberg. Here it definitely shows us that the early universe was a much more crowded, much more chaotic, and much more mysterious place, and involved a lot of activity we never imagined. But as always, we'll definitely come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support the channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.